Good morning, students. This semester our paper title is Financial Mathematics. Subject code HBME 19016, Unit 1, Simple and Compound Interest, Part 1 by S. Muruganandham, Department of Mathematics, Phase 2 Campus, Dr. MGR Education and Research Institute. The introduction of simple and compound interest. First one is, what is interest? When you borrow money from someone or use somebody else's money, have to pay a service charge to him. This amount is paid back to the lender along with the original amount borrowed. This is sometimes known as the cost of money, which does not belong to you, but you have to use it. This is extra amount is called interest. The original amount borrowed is known as the principal or capital in different situations. The sum of both principal and the interest is known as amount. There are some types of interest. The first one is, there are basically two types of interest. They are simple interest and compound interest. Interest calculation, the principle on which the interest is to be calculated, and finally the type of interest. Inside the methods of calculation are different. For advanced, the business application, the number of times of interest accrual in a year is required. This is known as compounding. First one is, we have to denote simple interest. Simple interest is dependent on rate of interest, time period, principal, and the principal remains the same at the beginning of all the periods. It means that the accrual of interest is linear. The next one is compound interest. Compound interest depends on rate of interest, time period, principal, and the principal increased by the interest amount at the end of each period. Interest for the next period is calculated on the increased principal. It means that the principal plus interest of one period becomes the principal for the next period. This goes on the total time period for which the compound interest is calculated. This period is called the period of compounding or the compounding interval. At the end of each test period, accrued interest is added to the principal, and this becomes the principal for the next interval. In other words, the interest earns interest, some call it reinvesting or cumulative. It means that the accrual of interest is not linear but exponential. The compounding may be yearly, half-yearly, quarterly, monthly, weekly. Daily is means continuously, indefinitely compounded. This list is easily understand the simple interest. For 1 year, principal amount is 100 rupees, nothing but changes in interest is 10 rupees. And the second year also, the principal 100 rupees and interest is 10 rupees. And the third year, 100 rupees, interest is 10 rupees. This up to total 100 rupees, interest in 80 rupees for 8 years. But in the compound interest, this comparison is 10% per annum. First year is principal is 100 rupees, interest is 10 rupees. Next year I have to add interest plus principal, is becoming a principal. Therefore, the second year the amount is 110. The interest is 11 rupees. The next year 110 principal plus last year interest is also is now 121 rupees is principal amount. Therefore, this year this interest is calculated 12.1% per annum. Therefore, the 8 years amount is 194.9 rupees. Interest is 90.5%. Therefore, totally 114.54% is interest is 114.5%. The next is the interest graph. First, there is nothing changes in the simple interest, but in the compound interest, the interest largely and slightly is increased on the year by year. The amount graph is also simple interest will slightly changing, but compound interest is year by year will increased by the amount. The formula for interest calculation, let's assume principal equal to P and the amount equal to capital A and the total interest equal to I, interest rate I expressed in percent per annum, time period equal to T expressed in years. Frequency compounding is N expressed is number of times in a year. This formula for the simple interest A equal to P plus I or a simple interest equal to PNR. Example, if P equal to 100 rupees, interest equal to 50, then A amount equal to 100 plus 50 equal to 150 rupees. Formula for simple interest I equal to PTI. It means P into T into I divided by 100. I by 100 is the rate of interest rate. Example, if the principal amount is 150 rupees, interest 12% per annum, and the time for the period T equal to 3 years, then the interest of the simple interest I equal to 150 into 3 into 12 by 100 into equal to, you have to simplify it lastly, we get the amount is 50 rupees plus 4 rupees interest. And the formula for simple interest, A equal to P into 1 plus T into I by 100. For example, if principal the amount is 150 rupees, I equal to 12% per annum and the period of time equal to 3 years, then amount equal to 150 into in the bracket of 1 plus 3 into 12 by 100. Have to simplify it step by step. Therefore, 150 into 1.36 equal to rupees 204 rupees. And the formula for simplification out of the 5 basic variables: principal, amount, interest, time period, and rate of interest. If you know any 3, then rest can be calculated by manipulating the formula. Please note that the simple interest can be directly calculated, but the compound interest can't be directly calculated. First the amount is calculated, and then the difference of amount and the principal is the interest. Therefore, the amount of equal to principal plus interest. If you want interest, then we go to the find out interest equal to amount to minus principal. If you want amount, P into 1 plus I divided by 100 and divided by N, power of T into N. The symbol of cap denotes to the power of. Cap name is power or raised to. I equal to rate of interest, T equal to time period, and N equal to compound frequency, P equal to principal, and capital A equal to amount. The examples, let's take the sample example as the previous slide. The graph of comparison, P equal to 100, T equal to 8 years, I equal to 10% per annum, and N equal to 1 time every year. Therefore, A equal to 100 into inside the bracket 1 plus 10 by 100 divided by 1, the power of 8 into 1. Therefore, 100 into simplified that the 1 by 10 to minus 1 equal to 1.10, the power of 8. Because 8 into 1, 8. Simplified that next line, 100 into 2.144 rupees. Therefore, simplified that rupees 114.4. So we have to calculate now interest in amount minus principal equal to 214.4 minus 100 rupees. It's equal to 114.4 rupees, which matches our result. The formula of the computer, how to find the rate of interest. If A, P, T are given but not given the interest. For simplicity, let's assume that N equal to 1. Then the formula is I equal to inside the bracket of A by P, power of 1 by T minus 1 into 100. For example, let's take this last example. Amount equal to 214 rupees, principal is 100 rupees, C equal to 8 years, and N equal to 1. Therefore, the I equal to 2 power 14.4 divided by 100 in the power of 1 power 18 minus 1 power 100. Therefore, simplify the equations step by step. 2.144 power of 0.125 minus 1 into the power of the 100. In lastly, we get 10% per annum. Some nouns. Simple interest is really used in today's world. Business, bank, statistics, finance, demography, population, accounting, everywhere the compounding interest in the growth and the increase are used. Because all and everywhere, usually in the finance world is not but not least, the simple interest is used in the bank everywhere. If the compounding interval is not mentioned, then it is assumed to be yearly. The compounding interval is never more than a year. It means the value in n is never less than 1. Some, the mentioning only the rate of interest without the compounding interval is incomplete information. Compound interval, the more the compounding frequency or the else in the compounding interval, the more the effective annual interest. The formula for calculating is the amount p into 1 plus I the 100 into power n by t into n, and the effective annual interest is a minus p. It means amount minus p. Example, let's say the principal amount is 100 rupees, I equal to 12% per annum, and the time the t equal to 1 year. N equal to 1, n yearly, 2 half yearly, 4 quarterly, 12 monthly, 52 weekly, 365 daily, etc. Let's calculate. For n equal to 1, yearly compounding, and the amount is rupees 100 rupees, and the time equal to 12 months basis. Therefore, we have to calculate the amount of 100 rupees, 100 into, inside the bracket 1 plus 12 by 100 by 1, the power of 1 into 1. Therefore, simply put the next line, 100 into 1.12 power of 1 equal to 112 rupees. Effectively, the rate of interest equal to 112 minus 100 by 100. Therefore, 12 by 100 equal to 12% per annum. For n equal to 2, half yearly compounding, it means 6 months every year the amount is collected. Therefore, the amount of 100 rupees is 1 plus 12 by 100 divided by 2 in the power of 1 into 2. Then equal to 100 into 1.06 power of 2 equal to 112 rupees point 36 pice. Effective of the I equal to 112.36 minus 100 divided by 100. Therefore, 12.36 pice divided by 100 equal to 12.36 per annum. Compounding interval for n equal to 4, it means quarterly. Every year have 4 quarters. Therefore, the amount to be calculated 100 into 1 plus 12 by 100 by 4, the power of 1 into 4 equal to 100 into 1.03 or by 4 equal to, we get 112.55. The rate of interest 112.55 divided by 100. It means in lastly we have get 12.55% per annum. If n equal to 12, it means monthly basis. Therefore, the amount is calculated by monthly. Therefore, the interest compounding monthly. Therefore, the amount 100 into 1 plus 12 by 100 by 12 power of 1 by 12. Therefore, 100 into 1.01 power of 12 equal to rupees 112.68. The effective rate of interest is 112.68 minus reduce the amount of 100. Therefore, interest divided by 100. In lastly, we get the amount is 12.68% per annum. For n equal to 52, it means weekly. Every year has the 52 weeks. Therefore, we have to conduct 52 weeks in every year. Therefore, the amount is 100 into 1 plus 12 by 100 by 12 in the power of 1 into 52. The amount is 100 is to be calculated 1.0023 power of 52 equal to get in last 112 rupees 0.73 with 34 pice. The effective of interest is I equal to 112.68 minus 100 by 100. In lastly get 12.734 pice in divided by 100 divided equal to 12.734 1.4% per annum. For n equal to 365, it means a daily day interest wages. Therefore, the amount compounding by daily. Therefore, the amount is 100 equal to 1 plus 12 by 100 divided by 365 power of 1 into 365 equal to 100 into 1.00033 power of 365 equal to 112.747. Effective I equal to 112.68 minus 100 by 100. 12.747 by 100 equal to 12.74 per annum is a half. Therefore, how to the daily wages of the amount interest collected by the daily in interest 12%, 7.4% per annum. The computing interest, if we know, keep increasing value of n further to say very high number or infinity. That means the interval getting smaller and smaller to say 0. This is known as infinitely compounding, for which the formula is a equal to p to e power of I into t. I means interest, t is the time of period. The content is the compounding, where e equal to base of natural logarithm equal to 2.71 e to 8. But there are few tricks. The I is expressed in decimal. Example 12% is 0.12. The t is expressed in multiple of the period of interest rate. If roll is the annum, then years or 6 months shall be 3.5 years. Let's take some example. The same example of principal amount is 100 rupees and the rate of interest is 12% per annum. If t equal to 1 year, then what is the rate of interest in 1 year? Therefore, the formula of amount equal to p into e power of I into t. Therefore, 100 into 2.71828 power of 0.12 into 1. Therefore, simplify that. 100 into 2.719 power of 0.12. The next step, 100 into 1.127497 equal to 112 rupees 0.7497. Therefore, the interest 112.7497 minus 100 equal to 12.7497 rupees. We see that if whereas the compounding frequency increases or interval decreases, the effective annual rate increases. So, in the limiting case, it is the highest yielding of all the other frequencies of compounding. Theoretically, it is the highest compound interest. For example, we have to see some examples in the amount of 1 year. Interval rate is yearly, n value 1 year, the roll is 12% per annum, effective annual roll is 12 rupees per annum. Then next, half yearly, 2 times every year, 12% per annum, then we get 12.3600. Quarterly, 4 times in every year, 12% per annum, 12.5509. Monthly means every year 12 months, 12% per annum, 12.61 get. Then weekly, 12% per annum, 12.7341. And daily, 12.7475. The continuous of infinity, 12% basically and slightly, 12.7497. You might have seen bank advertisement displaying 14 minus 1.5 effective annualized yield after that 5 to 7 to 10 years. Let's calculate. That is an exercise and see how they do it. The ABCD bank is given 10% per annum. Senior citizens for fixed deposits or bank interest are given quarterly compounded. Now, let's calculate the effective annualized yield rate for 5 to 7 to 10 years. The time of the period 5 years, n equal to 4 quarterly compound, I equal to 10% per annum. Therefore, the amount equal to 1 plus 10% per annum, the 100 divided by 4 in power of 5 into 4. Therefore, 1 plus 0.025 power 20 equal to 1.025 power 20. Then equal to slightly 1.6286. The interest in 5 years equal to 0.6386 into 5. Therefore, the interest 0.6386 divided by 5 in equal to, lastly we get 12.772% per annum. In case the time of the period equal to 7 years, n equal to 4 quarterly compounded. The interest database is 10% per annum. Therefore, the amount equal to 1 plus 10% divided by 100 divided by 4 into power raised in 7 into 4. effective of the amount is 1.99965 into 7 years. Therefore, interest rate is equal to 0.9965 divided by 7. Therefore, lastly we get the percentage of the rate is 14.236% per annum. In case the time of the period 10 years, but n equal to 4 quarterly compounded, it means every year 4 times we have to pay interest. And then I equal to 10% per annum. Therefore, amount equal to 1 plus 10% divided by 100 divided by 4 power of 10 into 4. Therefore, 10 into 4 means 10 into 40. Therefore, 1 plus 0.025 power of 20 equal to 1.025 power of 40 into the next step 2.685 I equal to in 10 years I equal to 1.685 by 10. Therefore, we get to the lastly 16.85% per annum. Lastly, we have to move to the conclusion. With the help of compound interest, one can trick others. Compound interest can give very high returns after long periods. Example, say a young man gets a lump sum from his father at the age of 25. If he puts it for 12% per annum till he retires at the 60 age. Let's compare the simple and compound interest. 12% per annum, 35 years equal to 4 to 20% or 4 to point per time. The amount will be 1 plus 4 point equal to 5.5 times. Compound interest 1 plus 12 by 100 point 35, 52.8. Hence, the return is 10 times in 30 years. Therefore, the power of compounding.